All right, so this is basically a continuation of our lesson on being able to write a quadratic function in vertex form, given we're starting in standard form, and our method is completing the square. So, as we've talked about, we need to create a perfect square trinomial that will become the x minus h quantity squared in our vertex form. So we've learned that this number, this minus 3, is no help to us, so we're going to move it out of our way by undoing it. So we're going to add 3 to both sides. And this is then going to give us over here f of x plus 3, which is a little weird looking right now, but that's what the math says, and that's what it is, so that's what we write. And over here we now have 3x squared plus 24x. So we've learned that in order to create a perfect square trinomial, the process is that we divide a number by 2 and then square it. However, we've also learned that process only works when our a value is 1. So that's our second step. And the way we change our a value from 3 to 1 is we're going to factor the 3 out of these two terms. So we factor out our a, which is equal to 3. So that over here then, we pull out our 3, and that gives us our 1x squared, and it gives us a plus 8x here. And then you always want to make sure, double check, make sure signs and numbers are all matching if you distribute your a, that you go back to what you started with. And over here on the left, we still have f of x plus 3. So now we're to the point to where we are going to figure out what to add after that 8x to create that perfect square trinomial that we need. That's going to become our x minus h quantity squared. So we've learned that we take our b value, which is this positive 8, and divide it by 2, and then that number we square. And so 8 divided by 2 is 4, and 4 squared gives us 16. What we have to be we also talked a lot yesterday about balance in our algebra, that we can't just add a 16 here without balancing the equation in some other way. So the way we're looking at here is that over here on the left side, after our f of x plus 3, we're going to have to add to this side too to balance. But you have to be careful here, because you're not going to add a 16, because the 16 is inside parentheses. So if we remove those parentheses by multiplying by 3, what we've really got is 48, because 3 times 16 is 48. So what we actually then do, and I would recommend that you put these arrows in your notes, we're going to take the 16 times 3, and that's the number that we put there. So that would be our 16 times our a of 3, which is 48. So now we're getting close to being done here. We have our f of x, and we're going to add our 3 and 48 together, and that's 51, so we get plus 51 equals, we have our a value of 3, and then this is our perfect square trinomial, so it will factor into two binomials that are the same. And if you can write it like this right away, that's fine, but you can also, of course, first just do the regular factoring into the two binomials and then rewrite it as the quantity squared. So x squared, we know we're going to use x and x, and then we need two factors of 16 that will give us a positive 8x, so that's going to be plus 4 and plus 4. So that means we get x plus 4 quantity squared. All right, and there's now only one more step, and we'll have our vertex form, and that is to subtract this 51 from both sides, and this is going to become our k value. So we subtract the 51, subtract the 51, and so now we have f of x equals 3 times x plus 4 quantity squared minus 51. And there is our vertex form. Now, as we've been discussing too, be careful. Remember that instructions sometimes have more than one thing to do. So it also says that we have to, at this point, identify the vertex and whether that vertex is a maximum or a minimum point. So I'm looking here at my h would be the opposite of this plus 4, so my vertex is going to be -4, -51. And then whether it's a maximum or minimum depends on whether there is an x-axis reflection. And since our a value is positive, there's no reflection, which means that this vertex is a minimum. And that then finishes the problem, all parts. All right, so for our next example here, we're doing the same thing. We have this function here called f of x. Process is the same. Here, though, our a value is already a +1. So because of that, in our second step, when we factor out a, we really are just factoring out +1, which doesn't change anything. So you could also look at it as you get to skip step 2, where you factor out a. So the first step, though, is to realize that, all right, this -8 does not help us with creating a perfect square trinomial. So we're going to move it out of our way. So we're going to add 8 to both sides. And so we're now going to have f of x plus 8 equals x squared minus 10. 10x, rather. And so our second step is to factor out a. But our a value here is already +1, which is actually what we need in order to use our procedure where we can create a perfect square trinomial. So when a is +1, you could also just sort of skip that step because factoring out 1 doesn't change anything. So you've still got f of x plus 8, and you will actually still have x squared minus 10x. If you want to write a 1 here, you can, but it's not absolutely necessary. And then we're going to figure out in the next step now what we're going to add after that minus 10x that will create our perfect square trinomial. So we've got our x squared minus 10x and plus something here. So procedure is to take our -10 here and divide it by 2 and then square that number. So that would be -5 squared. -5 times -5 would be +25. Over here on the left side, where we have our f of x plus 8, we also, again, this is where we have to balance our equation by figuring out what to add over here. So this procedure is the same, but this time we're taking 25 times 1, and 25 times 1 is just 25. So we get the same number in this case because a is 1. So now we are going to add these two numbers together. So we get f of x plus, and 8 plus 25 would be 33. And our perfect square trinomial over here, again, if you're comfortable with writing it directly as a quantity squared, that's okay. Watch your signs, or you can factor it separately first. So you'd have x and x, and we need two factors of 25 to get a -10x. So that's going to be a -5 and a -5. So that means this is x minus 5 quantity squared. So now I am going to do two things really here to get this into the vertex form we use in C. We're going to subtract 33 from both sides, and this is going to become the k value. And when I rewrite it, I'm also going to not write the 1, since anything times 1 is itself. So my final function becomes f of x equals x minus 5 quantity squared minus 33. And there's our vertex form. So now, just want to finish it up and not forget that last part where we have to identify the vertex. So our h value would be the opposite of the minus 5, so positive 5. K is negative 3, so the vertex is 5, negative 3. And A is positive, so there's no x-axis reflection. That makes our vertex here a minimum. And that finishes this problem. All right, and that will finish up the final problem of the lesson. Not that. Where are we? And you should be able to start your assignment now. Have a good day.